More than 1 million people are bitten every year by snakes. And of these, up to 100,000 die and 400,000 suffer from lifelong injuries. This is why the World Health Organization has declared snakebite as a neglected tropical disease.
Snakebite disproportionately affects people who are living in rural parts of the tropics, places in sub-Saharan Africa, South Asia, Latin America. And it's the rural communities that are at the greatest risk of a snakebite. People who are in the environment where there are venomous snakes, whether that be agricultural workers or children playing.
Antivenom is currently made by injecting venom from snakes into sheep or horses, and then the antivenom is created from the serum of these animals. So we basically use their immune reaction against the toxins to protect ourselves. However, this is available only in hospitals. It requires a cold chain, so it needs to be refrigerated, and therefore it is not easily accessible for people living in rural areas. Also, the treatment costs are incredibly high for farmers. The issue with producing antivenom from animals is that these animals have seen other diseases before, so it's estimated that only 15% of the antibodies in the antivenom actually are effective against the venom toxins. That means that you need multiple doses of antivenom, and this increases the costs and the risk of serum sickness.
One of the challenges with tropical snakebite is that different snakes have different types of toxins in their venom. And this means when someone's bitten by a snake, they can present with either bleeding disturbances or neurotoxic effects that paralyze them, or local tissue damage and swelling around the bite site. These different venom toxins also cause us a challenge when we're trying to neutralize them, because we have to inhibit the most important toxins found in the venoms of a diversity of snakes, and that includes all of those hemotoxins, neurotoxins, and cytotoxins. Using rational approaches to understand what is in a snake's venom enables us to target those toxins we need to neutralize with real specificity.
The way we currently produce antivenom is technology which is more than 100 years old. Obviously, with modern biotechnology, we can perform much better. Our antivenom project is an entirely novel approach to generate antivenom. It's based on our research on vaccines. We use a scaffold rather than monoclonal antibodies or antibodies in general for antivenom. We want to use a protein which is thermostable, which would avoid entirely the need to be refrigerated. The antivenom will be based on the ademer protein nanoparticle. It contains 60 binding sites for the toxins and will very efficiently neutralize it that way, much more efficient than antibodies that have only 2 binding sites. Each binding site can recognize a toxin and efficiently neutralize it, but because we have 60 of the binding sites, the toxins will never be released from the particle and can be cleared with the particle out of the human body. This is a whole new way of treating snakebite, and this is why we are so excited about antivenom.
One of the most exciting parts of the antivenom project is this ability for us to engineer molecules that can inhibit snake venom toxins. And we do this by first taking venom from a snake and identifying all of the toxins in the venom, and specifically which ones are most important to neutralize. We're then working in partnership with colleagues in Marseille who are expressing these toxins recombinantly, so we're no longer using them from the snake. And then in Bristol, we're then identifying binding molecules, the adimers and antibodies that can stick to these toxins that we want to inhibit, before we bring them back here in Liverpool to test how well our engineered molecules can actually neutralize those snake venom toxins. This allows these treatments to be 100% specific against snake venom toxins, unlike current antivenoms.
Because the ademer-based antivenom is more effective, this means that we need less doses, and this also will make it cheaper compared to conventional antivenom. And because we don't use animals, the patients will not develop serum sickness, and we can produce the antivenom at scale. Our vision is a completely new type of antivenom with unprecedented effectiveness that can be delivered in the rural communities with a device like an EpiPen. Currently, antivenom is funded by the European Commission and the Wellcome Trust. However, the problem is global, and there is currently an antivenom crisis worldwide. The impact of adenovenom could be huge.
To deliver change to snakebite treatment, we need partnerships, we need funding from donors, and we need to ensure that all relevant stakeholders are brought into this fight together. And it's only through that concerted effort that ultimately we're going to be able to address what is the world's most lethal neglected tropical disease.